Welcome to the DevPrime platform. Today we are going to talk about how to accelerate software development and develop modern applications. Companies make big investments in technology because they aim to implement a digital strategy for digital challenges. The huge demand for developers is provoking a shortage of skilled tech workers. We make the development process of complex applications easier, decreasing development costs, increasing productivity, and boosting time to market. If you imagine that it is difficult to hire talents, challenges are even bigger when it comes to application complexity, maintainability, scalability, and computational costs provoked by technological inefficiency. According to market research, software maintenance cost is more expensive than development costs, turning innovation investments harder. DevPrime provides new strategies to accelerate innovation. End-to-end developer experience. Simplify onboard using a modern architecture with smart features, which make easier new features development. Every new application is a production-ready cloud-native microservice, and they evolve continuously with features from DevPrime stack, which free your team to innovate business. Accelerate software development. Developers' productivity, maintainability, testability, accelerate time to marketing, better applications in production. Every application is a production-ready microservice. You don't need to get worried about software foundation. It saves money and investment, enabling a pathway to cloud-native applications. Here is the big picture of your digital strategy ecosystem. Most of your investments goes here in this purple highlighted zone, which represents your business backend applications. DevPrime is right inside of this digital core, boosting your application development and empowering your team. Deploy microservices in any cloud, like Microsoft Azure, Amazon, AWS, Google Cloud, Oracle Cloud, and so on. Expose APIs in any API gateway and using any kind of front end. DevPrime platform reduces an average of 70% of software development costs in every new project because it has built-in capabilities which support your team in the main industries technologies like REST, OpenAPI, gRPC, distributed system practices like distributed trace, observability, retry, circuit break, in addition a modern architecture, standardized in development leading to maintainability, tests, and productivity. In the way of digital transformation, we come from traditional companies and start to decouple legacy into business components with help from DevPrime platform, turning it into a digital company. For the purpose of demo, we bring a very common e-commerce scenario. We have two microservices here, order microservice and payment microservice. Here we have order microservice, which receive web requests, process in domain logic layer, then save its states at the database, and hence emit an event. This event is a fact, it's a business fact. It tells us that a new order has been created. So this event hence will be detected by another microservice, the payment microservice, that will react to it, process in the business logic layer, and then save its states in the database. Let's start by building this microservice, the order microservice. Allow me to introduce you DevPrime CLI, which is a command line utility that speeds up a number of daily steps in software development. Application development depends on foundations that involves a series of decisions made by your engineering team, which would take many weeks. Inside a project, how many layers we have what is the responsibility of each or one of these layers, and how they relate to each other, because each decision has consequences. Let's back to the DevPrime command line interface to create a new microservice. Here we are creating a new microservice. It's called order. Our state will be placed in MongoDB databases, and our string will be emitted through RabbitMQ async communication. Now we already have a new production-ready microservice here. And the process of creating a new engineering project that would take weeks has just happened here in seconds. Let's go open this project. This entire project was built with DevPrime, following the main industry standards, and technology is isolated. Decoupled from the business rules, which allows your software to evolve continuously. This project is already production-ready microservice, with technological accelerators to expose APIs, communicate through events, using relational or non-relational database models, integration with security providers, integration with other APIs, observability, and much, much more. Now it is time to run our microservice. Remember that we have a production-ready microservice from the beginning, so you start with a production-ready microservice. You haven't written any lines of code yet, but you already start with a production-ready application. Eliminate rework, misconception, and over-engineering. When we run the application, we see that in addition to the application engineering project, we also have a stack with intelligent behaviors. One of them is this log that shows us all the processes that happen inside the microservice. Developer itself don't need to do no extra effort to have it. Through this log, we can see that we have a string adapter on RabbitMQ, state adapter on MongoDB, and our web adapter is on endpoint localhost 5001 that we can access from our browser. This is a production-ready microservice, so this can be placed under an API gateway of your choice. Now we are going to write some business rules in this domain layer. These rules are written in the domain-driven design pattern, which represents the result of conversations with business areas. For the purpose of demo, I'm going to use some ready-made code from my business rules marketplace, remembering that these codes is up to you or your team to code. Now that we have business rules, we need to do some implementations based on industry standards, which will help us to persist our states or expose our API endpoints. To speed up this coding process, which is a part of developers' routine, we'll use the DP init accelerator in DevPrime CLI. DevPrime init analyzes business rules and does most of the coding work, implementing database persistence, API exposures, test models approach, mappings, and so on. After analysis, DP init accelerates a series of implementations that your team needs to do on daily basis during the life cycle of an application in order to keep architecture decoupled. Repository, ending points, let's run the application once again. When you run the API now, check it out. We now have ending points and a working API. So let's make a request. We got a success here. Microservice registers all the processes that happen in it, and you don't need to do no extra effort. You don't need to make no extra effort for this, because all applications with DevPrime have the same predictable behavior. So we can trace the entire path of requests, the web adapter, going through the application's domain layers and going to record its states on the database and emitting the events on an async way through RabbitMQ. So here we got stream out event. We're going to change tabs and show the other microservice, the payments microservice that we brought it ready. We can see that it has the same standardized and predictable behavior as the order, and the event we tracked in the order continues to propagate here through the payments, passing through all the internal layers of application process and finally writing on the MongoDB. Same situation here. Receive web requests, process on the business layer, save its states, emit events, detect events, react to it, make some processing on business layer, and save its states. We built it together, this microservice, this other microservice, and we brought ready this one to interact with. So in the order side, let's go to microservice order. We got an stream out event. In the payment side, let's go to the payment microservice. We got a stream in event. So the event comes from order to payment. This is async communication. But what happens when we lose communication with RabbitMQ? Let's suppose that our async communication service is out, it's down. Let's see it in practice. I'm going to drop my RabbitMQ service locally in my machine. As you can see, DevPrime String Adapter by itself takes a decision to retry, and then it opens a circuit break. At this moment, DevPrime String Adapters knows that RabbitMQ is out, so our async streaming communication service is down. And DevPrime String Adapter knows that and opens a circuit break. It's like when you are driving a car and you have a problem in your tire, but the car can't keep driving, the car can't keep going. Even though there is a problem, the car itself can deal with it. So it's a reactive API, so it reacts to this kind of situation. And now let's make a request under these circumstances. So what happened here? We have a problem in RabbitMQ communication, but our APIs keep responding and keep working. Here we trace our web request going through the applications layer, recording it on the state database, and then when it comes to emit the event, Microservice realizes that the string communication is out, so it starts a reactive resilience strategy and saves the event into a previously configured fallback. But we received an OK in the API, and that means that although there's an internal problem in the string service, our application does not stop. It continues to selling. It continues to work. Let's bring the RabbitMQ back. When we return the container, we notice that the string adapter retrieves the event that would have been lost and resends it. And we can see it arriving here in the payments microservice. This event that would haven't been lost, it's now recovered. And we still have a log where we can configure warnings for when a circuit break happens, or even know how long each service instability interval. Okay, we saw individual logs for applications, but I have a process which is a cross-application process because it starts on order and it keeps on payment. And you can have many additional microservices during this processing. It's a cross microservice process. DevPrime supports the Open Telemetry protocol, and all we need to do is to configure a collector. Let's do that right now. Let's enable to export it, and our distributed trace here comes to true. Now it's time to make some web requests. And let's verify then on an Open Telemetry tool. So we can see all the way from inside out, from order microservice, every internal layer, and communication with payment microservice, all internal layer. As you see, you can trace your request and event through all microservices involved in your processing. And it's made with no extra effort from your developer or your team, because every DevPrime application got the same predictable and standardized behavior. All you need to do is to enable the trace on your microservice settings. And you can also verify all these logs in some log analysis tool. Like this one here. So you can verify any failure or to investigate some strange behavior, which helps you to detect bugs really faster. In addition, DevPrime gives you a trace in order to keep tracking of failures in production. Let's request to our API and don't send customer name, which is a mandatory field. Let's see what's happening here. We got an error, so it's a 500 status code, which means we got an error, and there is also a trace ID here. This number helps us to identify this trace, this request. So based on this trace ID, we can see every step from where our request has been into. Start from web adapter through applications domain layer, and at domain there's business rules that say it's a mandatory field. As we saw on our API, customer name, it's required, it's a mandatory field. So in our log, we got more detailed information, which makes our root cause analysis faster and improves your mean time to recover and your mean time to repair. You can see this kind of log in Azure Analytics log or in collector of your choice. You can now use your DevOps process either on Azure DevOps, GitHub, or another tool to publish your preferred cloud provider.